Okay, what we have here is a basic calorimetry problem. So in a basic calorimetry problem, we have our fundamental condition is that the sum of the heats equals 0. So in this case, we have only two things to consider, the ice and the water. So I said water, T, whatever. Q for the T, I'm going to call that Q1 because I called it mass 1. So Q1 is equal to mass 1 C1 delta T1 because it's going to have its temperature changed. Now making some substitutions there, M1 is still M1. There's only one specific heat here, C, so I'm just going to change that to a C. And then my temperature difference is going to be my final temperature. So it tells us down here that we're going to reach an equilibrium temperature. So it's going to be whatever that equilibrium temperature is, temperature final, minus the temperature initial for that, which was 1. I better call it temp Q1. I'd better be more careful with my writing. Okay, now Q2 for the ice. What's the ice going to do? Well, the first thing the ice is going to do is melt. So if it melts, it's going to be mass 2 times the latent heat of fusion. Now, something to keep in mind is the direction of heat. Notice for Q1, the T is cooling down. So temperature final is lower than temperature initial. That means when I do temperature final minus temperature initial, it's going to be a negative value. That is a negative heat because I was calculating the heat that is flowing out, and in this case, that was flowing in this case, heat is flowing out. Boy, I hope I said that right. It's negative heat because heat is going from this. Q1 is leaving, and of course it's going into the mass 2. So mass 2 is going to be positive, and the first thing is mass 2 times latent heat of fusion. That's going to transform it from ice to water. But then we have a second part, so I'm going to call that A. I have a second part, Q2B, that's going to be heating up the water. So that's going to be mass 2 C2 delta T2. But of course, C is the same, so I can replace that with C. It'll end at the same temperature as the T, temperature final, minus, and it starts at T2. So now I have all of my heats written there, and I just have to put them into that summation. So shifting down because I ran out of space up there, the sum of the heats equals 0 is equal to M1C T final minus M1C T1 plus M2 latent heat of fusion plus M2C T final minus M2C T2. Now with all of that written out, all I have to do is solve this for T final. So I will note here in red that I have T final here and here. So I'm going to move everything that's not those two terms to the other side, and I'm going to factor out the M1, I'm going to factor. So what I'm going to have is T final times C times M1 plus M2 equals, now everything else moved to the other side, so it's going to change signs. So this is going to be positive, negative, positive. C times M1 T1 plus M2 T2 minus M2 LF. And so finally for my answer, T final is equal to C times M1 T1 plus M2 T2 minus M2 LF, all divided by C times M1 plus M2. Now let's compare what I just got to your answer, because honestly I had not compared it yet. If I look at your answer, I don't see the T2 term at all. You have this term, I will circle here. This here is right there, and this here is right there, and of course the denominator is exactly the same. That's supposed to be a different color, sorry. The denominator is exactly the same, but I think you can see that you are missing the black term. And if you're like the other student I helped, you might not actually listen to this, so I'm going to write down this term is missing. And now you have to ask, why did you miss that term? You missed that term, assumedly, because you forgot that you had it right there. Right, you do have, oh wait, are you missed? Yeah, you have this term accounted for, you just didn't account for that term. Okay, so there we can see our problem. Hopefully that helps. And I've got to stop this before